In this video, we are going to be solving this problem. What is the least number of weights required to weigh any integral number of pounds up to 63 if you are only allowed to put weights in one pan of balance? You can try to pause the video to solve this problem if you'd like. So onto our solution. Let's take a look at our balancing scale. On the right side, I will put 1 through 63 because, again, we have to weigh out every single value of this and balance it perfectly. On the left side, we need to find out the least amount of weights such that we can properly balance every single number from 1 through 63. So the secret to solving this problem is binary. We can use binary to encode this problem to make it a whole lot easier. Take 7 for example. In binary, 7's representation is 1, 1, 1. If you're familiar with binary, you know this means you have 1, 2 to the 0th, 1, 2 to the 1th, and 1, 2 to the 2. Now let's change this to the context of our problem. Let's say on the right side, we are not weighing 1 through 63, but we are actually weighing 7, just 7 on its own. The weight values we would use on the left side is just 1 4-pound weight, 1 2-pound weight, and 1 1-pound weight. Essentially, that's the binary representation of 7. Now let's try another number. Let's do 5. How do we weigh out 5? Well, 5's binary representation is 1, 0, 1. So in the context of this problem, instead of thinking as binary as zeros and ones, you can think of the 0 and 1s as whether you're using the weight or you're not. So in the case of 5, you are using the 4-pound weight, you are not using the 2-pound weight, and you are using the 1-pound weight. So now that we know how to convert this to our problem, let's solve the entire thing. Again, the problem was asking for weight values from 1 through 63, all of the weight values. We know that any number can be written in binary. So let's just make this easier for ourselves and notice that 2 to the 6th is actually 64. 63 is 1 less than that. So we can just start from 2 to the 5th. We will use a 2 to the 5th weight and so on. We will write all the way down to 2 to the 0th. These 6 weights are all we need to measure 1 through 63 pounds. Again, this makes sense because 1 through 63 can be written in binary using this amount of digits. So the answer for our problem is the least amount of weights we need is 6 weights. If you don't trust the math, you can try picking a number from 1 through 63. Write that in binary, and you'll see that using these 6 weights, you can definitely measure it. Thank you for watching, and please like, share, and subscribe.